Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 8 learners. Welcome to today's Natural Sciences lesson. My name is Patuchezo Singo, and this lesson is proudly brought to you by the Gauteng Department of Education. In today's lesson, we are going to be learning under the knowledge area matter and materials. The topic is particle model of matter, and then the subtopic, which is our main area of focus today, is density and state of matter, expansion and contraction. Now let's go through the lesson objectives. At the end of the lesson, you should be able to define expansion and contraction, describe what happens to a material when it expands and contracts, and describe the density of solids, liquids, and gases in terms of the particle model of matter, and then explain expansion and contraction in terms of the particle model of matter. Lastly, explain why gas, liquids, and solids have different densities. All this is from your CAPS document on page 43. Now let's go through pre-knowledge. So this is a trip down memory lane. So far in the 8th grade, we have learned about the states of matter and helped to explain the arrangement of particles in the 3 different states of matter, the spaces between the particles in the 3 different states of matter, and the energy that the particles possess in the 3 different states of matter. We've also learned about change of state, what is needed for a state of matter to change. And then last week we learned about density, mass, and volume. We defined it, and then we described the 3 as well as did some calculations. Now let's go through the baseline activity. So I'm going to read out the questions and then give you time to answer them. After that, we will go through the solutions together. Don't forget to send in any questions you may have or any responses to the questions to our WhatsApp number, which is 079 578 2908. All right, let's read the first question. Number 1. How can materials be made to change their state? Number 2. What are the 2 physical properties of a material that we need to determine density? Number 3. Blank have molecules that are pegged together and hardly move. Blank have a definite volume and molecules that are spread out and can move past one another. Blank have molecules that can spread out far from each other and move quickly. Take 5 minutes to do this activity, and then after 5 minutes, we will do the solutions together. See you after 5 minutes. Welcome back, learners. Now let's answer these 5 questions together. How can materials be made to change their state? Materials need to obtain energy or lose energy to change their state. And then what are the 2 physical properties of a material that we need to determine its density? We need mass and we need volume. So we'll need the material's mass and we'll need the material's volume in order for us to determine its density. Blank have molecules that are packed together and hardly move. Solids have molecules that are packed together and hardly move. Liquids have a definite volume and molecules that are spread out and can move past each other. And then gases have molecules that are spread out far from each other and move quickly. Take 1 minute to copy down these corrections, and then after that 1 minute, we will continue with our lesson. Welcome back, learners. Now let's continue with our lesson. So our next slide is on terminology. So these are the terms we are going to use during the lesson, and let's find out what each of these terms mean. The first term is density. Density, this is the amount of mass in each volume of matter. The amount of mass in each volume of matter. Dense, the amount of space an object takes up. And contraction, the process of taking up less space when a material slightly shrinks when it is cooled. Expansion, the process of taking up more space. To expand is to become larger, to swell up, or to increase in size. Now let's move on to density. We have defined density in the previous lesson. We have defined density in the terminology. Now let's try and explain what density is and describe it in terms of states of matter. Now, density is a process that compares mass and volume. So the density of a material, we have said, is the amount of mass in a particular volume. So we are comparing these 2 properties. So we need these 2 physical properties in order for us to be able to calculate density. Solids, liquids, and gases have different densities. Why is it so? This is because of the arrangement of the particles. So a material in its solid state will have a slightly higher density than a material in the same material in its liquid state, and then a material in its gas state has a much lower density. So if we take one material, we measure its density in its gas state, we measure its density in its liquid state, and we measure its density in its solid state. It will have 3 different densities. The highest will be in its solid state, followed by its liquid state, and then the least density will be in its gaseous state. This is for most materials. Now, so in general, gases are less dense when we compare them to liquids, and liquids are less dense than solids. Why is it so? This is because the particles within these 3 sets, the gas, the liquid, and the solid states, are arranged differently. So the way the particles are arranged is quite different. Now, can we look at this diagram that I've just put up here? So we've got the gas, we've got the liquid and we've got the solid. This arrow is showing us the direction in which density is increasing. So if we look at the arrangement of the gas particles, the arrangement of the liquid particles, and the arrangement of the solid particles. So the density is due to the arrangement. So gas particles have more space in between them, so we'll have less particles in them in a particular volume. Liquid particles have less particles than solid particles in a particular volume, and the solid particles will have the most number of particles, which increases their mass and therefore makes them denser. So the closer together also the particles, the greater the mass of that substance in a given volume, given that cube 1, cube 2, and cube 3 all have an equal volume. So as a result, what do we end up with? We end up with the solid generally having the greatest density, followed by the liquid, and then lastly the gases, because of the way the particles are arranged. The particles within a solid are closely packed together in comparison to the other two. Now, let's look at them closer. Let's say these circles. We measure the volume of these circles, right? So when you look at these circles and you look at the arrangement of the particles, so because of the way solid particles are arranged, they are very close to each other, they hardly move, and the spaces between them are very small. So we'll have more solid particles within this given volume. If we move on to the liquid, yes, they are closely packed to each other, but they have the spaces between the particles are bigger when we compare them to the solid, so we have less of them in this given volume. Now, with the gas, remember the gas fills up the available space, so within this given volume, which is equal to this one and this one, we have less gas particles, which means that our mass is even less. Now, we have an exception to the rule. Let's explain the density of water. So when water freezes, what do we get? We get ice. So when water freezes, the particles between the water, they become larger. This is water as an exception. So once frozen, the same mass of water now occupies more volume. The same mass of water now occupies more volume. Remember, the number of particles do not change. The size of particles do not change. So what changes is the energy they possess and the spaces that exist between these particles. So once frozen, the same mass of water now occupies more volume. Why? Because the spaces between the particles increases, and then water liquid is then denser than ice. Now the particles of water liquid, so in the middle here, this is where we have water as labeled down here, then we've got ice, and then we've got our water vapor. Now, if you look at the spaces between the water vapor particles, they are the largest amongst the three. So the molecules of the water vapor, which is the gas, they have bigger spaces between them. So when this gas condenses and becomes a liquid, now those spaces decrease. The spaces between the particles decrease, or the spaces between the molecules decrease, and then our gas condenses and turns into liquid water. Now, if we remove energy, remember, to change the state. To change the state, you need to either add energy or remove energy. Now, to remove the energy, what will become of the water? So when we remove energy, or when we cool our water to a point where it freezes, the spaces between the water particles or the water molecules increases. So this is what the arrangement will look like. Yes, it will be a solid. Yes, it will have a rigid shape where its particles hardly move, but the spaces are going to be bigger. The spaces are going to be bigger. So what does it mean to us? What does it mean? It means water and ice, these two are an exception when it comes to density, because remember, we generalized and said solids are generally denser than liquids and gases. Liquids are generally denser than gases, okay, with water being the exception. So now ice, which is water in a solid state, is less dense than liquid water. This is why ice floats on water. When you take your ice cubes and add them to a cup of water or a glass of water, they are going to float because ice is less dense. It is less dense than water. That's why you have icebergs floating in that big ocean, in the big seas, because ice is less dense than water. Because when water freezes, the particles, as they become solid or as they change their state from liquid to solid, the spaces between them increases. So the spaces between them increases, making ice less dense than water. And now let's talk about the density of a gas. So the density of a gas is not fixed. Why? Let me show you. Now, solids and liquids do not change their volume, therefore, their density is fixed. Remember, density depends on which two physical properties? It depends on mass, it depends on volume. Now, the volume of a gas is not fixed. Remember, when we were first learning about the particle model of matter, we said what about the volume of a gas? It is subject to change depending on where the gas is, or if you put a gas, it fills the available space. So if you put water vapor inside a 500 milliliter container, it's going to fill up the space. So therefore the volume will be 500 milliliter. If you take the exact same gas with the exact same number of particles and move it into a 1 liter container, what is going to happen? It is going to change its volume to 1 liter. So therefore the density of a gas, it is not fixed, because the volume of a gas, it is not fixed. It can change. If we look at these three pictures, so this is, we've got a solid here, we've got a liquid, and we have a gas. So the solid will hold its shape. Holding its shape means holding its volume, holding the amount of space that it is taking up. So it holds its shape, which gives it a fixed volume. So if you multiply your length times your width times your height, you still come up with the same volume. So it holds its volume. With the liquid, we know liquids flow. Liquids flow. You can pour a liquid. So they take the shape of the container, or whichever part of the container that the liquid is occupying. It has a free surface and also a fixed volume, regardless of where you pour it into, from a round glass to a square glass to a rectangular glass, any type of container that you pour it into, it retains its volume. It has a fixed volume. So fixed volume, fixed mass means fixed density for this particular amount. And then with the gas will take the shape of the container, therefore it will take the volume of the container. So if you move the gas from one container to another with different volumes, it will change its density. And if you move the liquid to a different container, it will still keep its density. It has a fixed volume, so therefore it has a fixed density, same as the solid, also same as the solid. So this is why we say a gas does not have a fixed density. Now let's talk about compression. Now, the high density of a solid explains why it cannot be compressed. Its particles are closely packed to each other with very small spaces between them. The spaces that exist between solids are very, very small, and the particles are tightly packed. So they're tightly packed with very small spaces. What does it mean when, or what does this tell us when we want to talk about compression? Can we compress a solid? A solid cannot be compressed or cannot be squeezed any closer together into a smaller volume due to the way the particles are packed. Liquids are also quite dense. It is very difficult to compress a liquid. So the density of a liquid is roughly the same as the density of as the density of the solid state of the same substance, with the exception of water, of course. So it will be very difficult to compress it because of the distance between the particles. The particles are close together. Even though they are not locked in fixed position, they can flow over each other, under each other, move past each other. That's why we can pour a liquid. So most liquids cannot be compressed into smaller volume. Take note, I said most liquids. Now, this picture shows us an activity that was done to try and compress a solid, which is chalk powder, a liquid, water, and air. So the same type of syringe was used, and the same volume of matter was also used. The solid was not compressible. The liquid was also hardly compressible, whereas the gas was very, very compressible. So the gas is very compressible because why? The spaces between the particles are very big, so it's easy to reduce the space. Now let's talk about the spaces between the gas, a liquid, and solid particles, and why we say we cannot compress them. Now, particles of a gas, we have learned so far that they have very big spaces between them. So the particles of a gas have very big spaces between them, and the particles of a liquid are close together. The particles of a solid are much closer together. So that is the arrangement of the particles in these three states according to the particle model of matter. So what does this mean to us? This means that in the same amount of space, gases have less matter than liquids, and liquids have more matter in the same space, and solids have the most amount of matter in the same space because of their arrangement. So the smaller the spaces between the particles, the larger the number of particles can be filled in that space, and the larger the spaces between the particles, the less number of particles can be fixed in that space. Let's look at this diagram here. You see, these cylinders are the same size. They are the same size, or they are the same volume. So with a solid, we can pack in more particles in this given space in comparison to the liquid and to the gas. See, the gas particles have larger spaces between them. So because of that, we are able to compress them. Because they have large spaces between them and fewer number of particles, or less matter. Solids have smaller spaces between the particles, so they have more matter and therefore cannot be compressed. Okay, so since we now know that dense gases are not very dense, why? Because of the large spaces between the gas particles. So this means that they contain a small number. They contain a small number of particles in a large space, or in a large volume. So this is why we are able to do what? To compress them and to squeeze them together to make sure they fit into a smaller volume. Now let's look at this picture here. So the red circles represent the gas particles with large spaces between them. So we are able to compress them and bring them closer together. One, there are fewer in this large space. Two, they have large spaces between them, so we are able to do what? We are able to compress them. We can compress them. For example, you can pump more air into a tire and blow more air into a balloon. What are you doing? You are simply increasing the number of particles into that balloon. You are simply increasing the number of particles into that tire. So therefore, the density can change. Introducing more particles changes which physical property? It changes the mass. And you can change the density of a gas. By adding more particles, you can blow more particles into a tire, and you can blow more particles into a balloon. Now let's do this activity. I'm going to read out the questions and then give you time to answer them. Don't forget to send any questions you may have to our WhatsApp line, which is 079-578-2908. Let's read out the questions. So the containers below have the same volume and are made of the same material. We have container A, container B, and container C with materials that are in them. Now, which container A, B, or C contains the greatest number of particles? A. B. Which container contains the smallest number of particles? C. Which container A, B, or C contains the material with the greatest mass and why? So you need to tell us why you're saying so. D. Which container has the smallest mass and why do you say so? E is divided into two parts. Which state has the highest density? Is it solid in container A, liquid in container B, or gas in container C? Or which state has the lowest density and why do you say so? Take 5 minutes to answer these questions. Then after 5 minutes, we will do the corrections together. See you after 5 minutes. Welcome back, learners. Now let's answer these 5 questions. Which container, A, B, or C, contains the greatest number of particles? Which one is it? It is container A. Container A has the greatest number of particles. And which container has the smallest number of particles? It is container C. Just by looking or by counting, you can tell that container C has 1, 2, 3, 4, 5, 6 particles, whereas B and A have more. And then which container, A, B, or C, contains the material with the greatest mass and why? It is container A. Why are we saying so? So the container with the most number of particles will have the greatest mass. Therefore, container A has the greatest mass. Take 1 minute to copy down the corrections. Welcome back, learners. Now let's answer the last 2. Which container has the smallest mass and why do you say so? It is container C. Why? Because the container with the least number of particles will have the least mass, and which state has the highest density? So the solid in container A has the highest density. Why? It is because it has the greatest mass. The greater the mass, the higher the density. And then the gas has the lowest density. Why? It is because it has the smallest mass. The smaller the mass, the smaller the density. Now, take 1 minute to copy down these corrections. Welcome back, learners. Now let's move on to expansion and contraction. So thermal expansion is an increase in the size of a substance when the temperature is increased. The particle model of matter theory helps us to explain thermal expansion and contraction that occurs in most solids, liquids, and gases. It helps us to explain because not every time is it when the temperature is increased does a substance change its state. Sometimes it expands and sometimes it contracts. Sometimes it expands and contracts. Now let's learn about the effect of heat on substances. So when a substance is heated, it increases in size. We say the substance expands. So it first increases in size before it reaches that point. It could be the melting point where a solid turns into a liquid. So before the solid reaches the melting point, when it is heated, it is going to expand. And this process is called expansion. This process is called expansion. Say we have a plastic bottle covered with a balloon. Within this plastic bottle is a gas. If we take this gas and heat it by means of placing the bottle inside a water bath that has hot water, what is going to happen is the gas inside is going to expand. Expansion can then be seen on the inflated balloon. The balloon becomes bigger. This is because the gas would have expanded. It would have expanded. Now, what are the effects of cooling? When a substance is cooled, it decreases in size. So before the gas condenses into a liquid, what is going to happen? The gas will decrease in size. All right, so we say the substance contracts, and this process is called contraction. That's the name of the process. Now let's look at this illustration to further explain what we mean. So if we take a gas that has expanded from the previous slide, so the gas has expanded inside the hot water in the hot and the water bath. So the gas would have expanded and inflated the balloon. So if we take the same bottle and place it in a water bath with cold water, what's going to happen? The balloon will deflate. It will deflate as the gas would have contracted. The gas would have contracted due to cooling and due to loss of energy. So what is then the effect of increasing temperature on different materials? Now, as a material is heated, the movement of particles changes. How does it change? So the movement of particles increases. They start moving faster and faster as they now have more kinetic energy, and they move further and further apart, and therefore the material expands. Let's look at this thermal expansion of a solid. So we have a solid here. You can see the particles are close together. They are arranged in a regular pattern. Now, so this is before we heat the particles. So remember, particles are in constant motion, and particles within a solid are doing what? They are vibrating in that fixed position. So they are vibrating within that fixed position. If heat is added, if we add heat to this material, if we heat this material, what is going to happen? The particles will start moving faster. They have more kinetic energy because of the heat that has been added. So they have more kinetic energy. They start vibrating more and more and more. Now, as they vibrate more and more and more around that fixed position, the spaces between them increases. The spaces between them increases. This is when the material would have expanded. So this is what happens if you heat a material and it doesn't change its state, or this is what happens before the point at which that particular material changes its state. Now, what is the effect of reducing temperature? So we've learned about the effect of increasing temperature. What is the effect of reducing temperature on material? So as a material is cooled, the movement of the particles decreases. You've removed energy, so they lose their kinetic energy and start moving slower and slower and slower. As they are moving slower and slower and slower, they are moving closer together, and therefore we say the material contracts. So this is when temperature is reduced or energy is removed in this direction. So we start off here where the particles are vibrating at a faster pace. So these lines around the circles represent the vibration. So as they are vibrating at a faster pace, removing energy or reducing temperature or cooling leads to contraction. You see the spaces between them before and the spaces between them after are quite different. So the spaces have reduced because the material has been cooled, the particles start moving slower, and therefore they come closer and closer to each other. So this is the opposite of adding heat. So cooling is the opposite of adding heat. Now let's talk expansion and contraction. So when a material expands or contracts, the size and number of particles does not change. Let's read that again. When a material expands or contracts, the size and the number of particles does not change. Instead, it is only the spaces between the particles that gets bigger or smaller. So when a material expands, the spaces between the materials becomes bigger. When a material contracts, the spaces between the material get smaller. Now, let's prove that point. Let's say we add heat to T1. We add heat to T1, then the spaces between the particles of T1 increases. But are the number of particles the same? Is the number of particles the same? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So T1 has 16 particles. Let's count how many particles does T2 have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the number of particles has not changed. If we look at the circles, they are still the same size, so the size of particles does not change. What changed was the spaces between them. So the spaces between the particles in T1, in T2 is different from the particles in T1. T2 is at a warmer temperature than T1, and T1 is at a cooler temperature than T2. So what changes is the spaces between the particles. The size of the particles and the number of the particles does not change when a material expands or when it contracts. Now, some materials become slightly larger when they are heated. We say they expand. And materials also shrink lightly when they are cooled. We say they contract. Now, engineers take this into consideration. They know that materials can expand. They know that materials can cool depending on how hot or cold the environment is. So they design workpieces in a manner where they are able to expand, retain their shape, and shrink and still retain their shape and not to crack or break when they are in use. So materials slightly shrink in cooler temperatures and slightly expand in smaller temperatures, and all this is taken into account when designs are being made. Now we said during expansion, the spaces between the particles get bigger. You see, before heating, look at this arrangement. Look at the spaces between the particles. After heating, you look at the arrangement as well as the spaces between the particles. So after heating, the spaces become bigger, but the number is still the same. The shape is still the same. There's only a change in the space between them. So during cooling, the spaces become smaller. So this is when the material is in a colder temperature, and this is when the material is in a hotter temperature. So if we cool this material, the spaces become smaller. The particles come closer together. As you can see, these ones are now closer. They are closer to each other. Now, how does a thermometer work? So a thermometer takes advantage of the expansion and contraction of materials. A thermometer is usually made up of a small hollow glass. So there's a small hollow glass tube, and at the bottom of it is a bulb which holds the liquid. It could be alcohol, it could be mercury, and then outside, so the smaller tube is inside another tube. Then we have graduations that will tell you your body is at 35 degrees Celsius or is at 40 degrees Celsius. Now, when there is an increase in heat, when the temperature increases, the liquid that is inside the bulb expands, pushing up the tube. And when there's a decrease in temperature, the liquid inside the material contracts, moving down the tube. So this is when the thermometer is in an environment that is cool. As you can see, the liquid is all the way down here. If there is an increase in temperature or we add more heat, the liquid will expand and move up the tube. Remember, the spaces between the particles are now increasing. The spaces between the particles are now increasing, so they want more space. They want to fill up more space, so they will move up the tube. They will move up the tube. Now let's do this second activity together. In this activity, we're going to compare expansion of different solid materials by drawing a graph. You will need the following information for your graph. So this is the information that we're going to use. We've got a table with materials: brass, iron, steel, platinum, alloy, concrete, ordinary glass, and overproof glass. And we are told how far in millimeters 100-meter length of the material will expand when the temperature increases by 10 degrees Celsius. Number 1, draw a bar graph. Draw a bar graph with expansion on the y-axis and materials as categories on the x-axis. Choose an appropriate title for your graph for 5 marks, and then which material expands the most upon heating, which material expands the least, and then which solid would be the best material to reinforce concrete. Hint: the reinforcing material should expand as much as the concrete, otherwise it will damage the concrete during expansion. Take 5 minutes to do this activity, and then after 5 minutes we will do the corrections together. Welcome back, learners. Now let's answer the questions together. So we're required to draw a bar graph with expansion on the y-axis and materials as categories on the x-axis. So this is the bar graph. So this is how a bar graph is marked. So the total number of marks for this bar graph is 5. You are also required to choose an appropriate title for your graph. So if you chose an appropriate title, a bar graph representing the expansion of different materials, you get your mark. For knowing which one is the y-axis and labeling it, you get your mark. And then for the knowing which one is the x-axis and labeling it, you get your mark. For putting appropriate spaces between the bar graph, you get your other mark. And then drawing them accurately, you also get your other mark. So those are your 5 marks for the bar graph. Let me quickly erase the notations, the ink notations, so that you can take 2 minutes to copy down this bar graph. Welcome back, learners. Now let's answer the rest of the questions. Which material expands the most upon heating? Which one is it? It is brass. As you can see, it expands 19 millimeters. It is the highest, or it is the tallest on the graph. And which material expands the least? It is the oven-proof glass. And which solid would be the best material to reinforce concrete? Here's a hint. The reinforcing material should expand as much as the concrete, so which means the expansion or how much it expands should be similar or the same as concrete, otherwise it will damage the concrete during expansion. It is of course steel. It expands the amount as concrete, the same amount as concrete. All right, grade 8. Now let's wrap up our lesson. What did we learn today? We learned that in general, Gases, they are less dense than liquids, and liquids are less dense than solids, with the exception of ice, because ice this is a solid and it is less dense than water. And this is because of the way the particles are arranged and the mass of the individual particles. So this is what makes a material more dense than other material, or materials less dense than other materials. We also learned that most materials will expand when they are heated and contract when they are cooled. This is because heating makes particles move further and further apart, and cooling makes them move closer and closer together. Alright, in our next lesson, we're going to learn about the density of different materials, pressure, and chemical reactions. Okay, grade 8. Until next time, thank you so much. Bye-bye.